In Chapter 6, we're going to be looking at triangles that are no longer right triangles. So triangles that do not necessarily have a right angle are called an oblique triangle. In order to solve oblique triangles, we need to know the measure of at least one side and any two other measures. When we say we're going to solve an oblique triangle, or any triangle, we are going to find all three sides, the measures of those, and we're going to find the measure of all three angles. The things we know fall into four cases. We may know one side and two angles. That side may be in between them, in which case we call it angle, side, angle, or it could be not between them for angle, angle, side. We could know two sides and the angle opposite, SSA. We could know all three sides, or we could know two sides and the angle that is in between those two. The law of sines is a relationship between angles and sides that can be used to solve oblique triangles, in particular cases 1 and 2. So if we label a triangle and we call the vertexes angles A, B, and C, and our sides are going to be lowercases a, b, and c, where lowercase a is across from angle A, lowercase b is across from angle B, and side C is across from angle C, then the relationship that we will see is that the length of side A divided by the sine of angle A is going to equal the length of side B divided by the sine of angle B, which is also equal to the ratio between the length of side C divided by the sine of angle C. So let's use this to actually solve a problem. In example 1, we are told that we have triangle EFG. We want to start by drawing a triangle. Okay, the length of sides doesn't matter, it doesn't have to be a right triangle, it doesn't even have to be pretty. But we're going to label our vertices, and those are going to be E, F, G. And we know that the measure of angle E equals 43 degrees. And we know that the measure of angle G equals 57 degrees. And we know that side E equals 4.56. Remember that if this is lowercase e, then it's going to be opposite my angle E, so it's over here. We're going to solve the triangle, so we are going to find our third angle, and we're going to find the length of the other two sides. So the easiest thing to start with is we want to know what is the measure of angle F. Well, we know the total angles inside a triangle add up to be 180 degrees. And so I know that 180 equals 43 plus 57 plus the measure of angle F. So when I solve this equation for the measure of angle F, I get 180 minus 43 minus 57, which if you just put this in your calculator, you get 180 minus 100, or just 80 degrees. So that is our third angle, and let's go ahead and notate that on our triangle. So that is now 80 degrees. While we're looking at angle F, we can find side F. So we know that that length of this side over here, that's F, is going to be in a ratio with the sine of angle F, and that is going to be equal to the length of E divided by the sine of angle E, and we know 3 out of our 4 variables in this proportion. So we're going to find F, but we know that the sine of F is going to be the sine of 80 degrees, which is just some number that when we put in our calculator, we can get a number. And that is going to be equal to, the length of side E is 4.56, and then the sine of angle E is the sine of 43 degrees. Again, that is just some number that our calculator will give us. When I rearrange this proportion, we can do this by cross multiplying, or in this case, I could just multiply both sides by the sine of 80 degrees. I get that the length of side F is going to equal 4.56 times the sine of 80 degrees divided by the sine of 43 degrees. Now this is just something I can put into my calculator, which when I do, I get a value of 6.58 units. We don't know what our units are here, so we're just going to put this into our diagram. So the length of side F is 6.58. The final thing we need to solve for is the length of side G, which is opposite angle G. And again, we're going to use a very similar proportion. We know that E over the sine of angle E is going to equal the length of side G divided by the sine of angle G, according to the law of sines. And we know 3 out of the 4 things in this. And so again, E is 4.56, and angle E is 43 degrees. We know that that ratio is equal to G, which is what we are solving for, divided by the sine of angle G, and G is 57 degrees. We now have a proportion we can solve for G. G is going to be 4.56 divided by the sine of 43 degrees times the sine of 57 degrees. I now have something I can plug into my calculator, and when I do that, I get the length of side G is equal to 5.61 units. So in our diagram, G equals 5.61. We now know all 3 angles, and we know the length of all 3 sides, so we have now successfully solved the triangle. In our next example, we're going to be looking at a pole that is tilting towards the sun. So if we think about the ground, and we have a pole that is not quite vertical, and the sun is over here. And this angle here is going to be 8 degrees, all right, because we are at an angle of 8 degrees from the vertical. It casts a 22-foot shadow. So 22 feet is our shadow. The angle of elevation from the tip of the shadow to the top of the pole, so from the tip of the shadow to the top of the pole, okay, that angle is 43 degrees. And we want to know how tall the pole is and what case this is. Okay, so the first thing we have to figure out is what is our angle here. We have a 90-degree angle between the horizontal and the vertical, plus 8 degrees. So this is a total of 98 degrees, which means because we know 2 angles and the side between them, that this is angle with the side in between, so angle, side, angle for the case. Now to find how tall the pole is, what we are looking for here is the length of this side. So we want to know this length, and so we know that that length divided by the sine of 43 degrees, which is the angle opposite, is going to equal the one length that we do know, which is 22 feet, divided by the sine of the angle opposite that, which is going to be this angle here, which we don't know yet. So there's going to be some angle in here. In order to find that, we know that the entire triangle, the interior angles add to be 180 degrees. And then we know that one angle is 98, so we've accounted for that. And then the other angle is 43. And so 180 minus 98 minus 43 is 39 degrees. So this total angle here is 39 degrees. So that's what's going to go into our proportion. And then when I solve this for L, L equals 22 feet times the sine of 43 degrees, because I multiply both sides by that, divided by the sine of 39 degrees, because that's still on the bottom of that fraction on the right. And when I plug that into a calculator, I get that the length of the pole equals 23.84 feet. In our next example, we're looking at the course for a boat race. It starts at point A, and it then proceeds in the direction 52 degrees south, 12 minutes west, which when we navigate, this is called a bearing. And we're going to want to use a compass rose, which is our north, south, east, west diagram to figure out what this looks like. So 52 degrees south and then 12 minutes west is going to be somewhere in this vicinity. So we're going to be going mostly southwesterly, but not directly southwest because it's not exactly 45 degrees southwest. And so we know we can draw a picture that looks like this. So B is going to be over here. Okay, we'll come back to what that actual angle is in a minute. And then we're going to go south 40 degrees, but 5 minutes east. So that's going to be kind of that southeasterly direction to point C. And then finally back to A. And that one we know is 8 kilometers due north. Okay, so let's label our starting and finishing point, and we want the total distance, which means we are going to add the 3 legs together to get our total distance. We're taking the perimeter. And so now we just have to figure out what the length of the other 2 sides are. For angle A, so 52 degrees, 12 minutes is going to be 52 degrees plus 12 sixtieths. Remember, there are 60 minutes per hour, so you can remember it that way. And that is equal to 52.2 degrees. And so we can label that as 52.2 degrees to point B. And then angle B, which is going from B to C, 40 degrees, all right, plus 5 sixtieths now is going to be 40.08 degrees. But that is in the southeasterly direction, which means if we drew our compass rose starting at B, that would be 40.08 as this angle, which since this is a vertical line, and we know from A to C is a line that goes directly from north to south because of this piece of information here, this side here, length BC, becomes a transversal, and so I know my alternate interior angles are congruent, so this is actually the 40.08 degree angle, meaning that angle B is going to be what's left out of 180 degrees. So 180 minus 52.2 minus 40.08 equals 87.72 degrees. So that is actually the angle that is here. And now I have enough information. I can find the length of side AB and the length of side BC, which I can then add to get the total distance of the race course. We know that the ratio of the side opposite angle B, which is 8 kilometers, divided by the sine of angle B, which is 87.72 degrees, is going to be equal to, let's start with side BC. So we're going to solve for that. So that is the length of side BC in the top divided by the sine of 52.2 degrees, which when I cross multiply and solve for BC, I get that it is equal to 8 times the sine of 52.2 degrees divided by the sine of 87.72 degrees. When I put that into my calculator, I get that that side's length is 6.32, can't forget our units, kilometers. We're going to use a similar process to solve for the length of side AB, which is opposite side C. So we know that the length of AB divided by the sine of 40.08 degrees is going to equal that same proportion, 8 divided by sine of 87.72 degrees that we've seen before. Cross multiplying to solve for AB, we get that AB equals 8 times the sine of 40.08 degrees divided by the sine of 87.72 degrees, which when I put that into my calculator, I get that length is equal to 5.15 kilometers. I now know all three angles and all three sides, so I have solved my triangle. But remember, we are looking for the total distance of the race course, which means I must add up all three sides. When I do that, I get that the total race is 8 kilometers plus 5.15 kilometers plus 6.32 kilometers, which means that that grand total is 19.47 kilometers. We are hopefully familiar with the area of a triangle as being 1/2 the base times the height. But what happens if it's not very clear what the base is and what the height is? Well, it turns out that for any triangle, whether it's an obtuse triangle, acute, or a right triangle, meaning any triangle, we can find the area using one of the three equations below. What you will notice is that for each one of these, there is a 1/2, so that is still the same. And then we have two sides, okay, the three different combinations. And then we have the sine of the angle that is in between those two sides. So in our example 4, we're going to find the area of triangle ABC. So let's start with drawing our diagram, and we'll label the vertices A, B, and C. Remember, the length of side A is going to be opposite angle A, so this side is 7.5. The length B is opposite angle B, and we know that the measure of angle C is 100 degrees. Now what we know is we have two side lengths, and we have the angle in between them. In this case, it happens to be A and B and C. So we're going to use this equation. But really, as long as you remember that this needs to be side, angle, side, where we know the angle in between the sides, that we are going to end up using the equation 1/2 times side 1 times side 2 times the sine of the angle in between. Okay, so this only works for side, angle, side, which we have in example 4. So let's plug this in. We know that the area is going to equal 1/2 A times B times the sine of C, which equals 1/2 times 7.5 times 9 times the sine of 100 degrees. These are all things I can put into my calculator, and when I do that, I get my answer for the area as 33.23, and it didn't give us units, but we have to include them even if we don't know what they are, so we put a placeholder. Units, it's area, so it's squared.